Okay, so we were talking about polyatomic ions, or I was anyway, because inside a polyatomic ion you've got covalent bonds, but among them, between them, you've got ionic bonds. There's one overall ionic charge. Well, actually, Amarantz, you need to be up in this front seat. Yeah, and
way to do a bus safety thing. So
huh?
There's a way to do a bus safety thing.
Bus safety thing, yeah. Sorry. Yeah, so K before L and then M. So just like the airline, KLM. There we go. All right, so yes, this empty seat in the front. Thank you. Okay. Sorry about the delay there, everybody. So again, they are like just a big ion. They don't react. Once sulfate is sulfate, it stays sulfate. Okay, it's going to be SO4 2 minus. The oxygens in the sulfur inside there, you don't need to worry about what's going on inside there. They're not going to react. The entire sulfate is going to react. Same thing with the phosphates. The oxygens aren't going to leave the phosphorus. There's not going to be something new coming into the phosphorus. Now, there might be a hydrogen or something that attaches to the oxygens way out there, but that's what ions do. They attach to positive things. So when you have these things, they're not going to break apart. They're not going to break apart, except the occasional hydrogen popping off or on. And again, down here with ammonium, that hydrogen, that fourth one, may pop off and make ammonia. But generally speaking, the oxygens and whatever they're attached to for the central atom will stay the way that they are. And the central atom is like in the tetrahedral form or the trigonal planar or whatever you have, is almost never oxygen, except in water. Except in water. Oxygen's usually going to be on the outside because oxygen doesn't like to bond with other oxygens. And if you look at this list, there's a lot of oxygens in here. So couple of rules of thumb: oxygens don't like to be with oxygens, and they don't want to be in the middle, except for water. Water, they'll be in the middle. Questions about that? Okay. All right. Now, the endings of the names in hypochlorite and carbonate. There's ite and ate. Okay. And so, ate is greater than ite. Ate will have more oxygens than ite will. So there are sulfates and there are sulfites. Sulfate has one more oxygen, one more element, 8, than sulfite has. SO3 2 minus versus SO4 2 minus. Hypochlorite, if you have chlorite, there will be ClO2 1 minus. So it'll be 2 oxygens there. If you have chlorate, then it'll be ClO3 and then 1 minus. And guess what perchlorate would be? See the pattern? 1, 2, 3. What's the next number? 4. Very good. Right. 4. So that is perchlorate. And a lot of different things happen. By the way, they all have a -1 charge. So even though you've got 5 atoms in there, and 4 of them are oxygen, which like to be negative, the whole thing actually just has 1 negative charge. It's very close to being neutral, but not quite. But anyway, carbonate has as many oxygens as possible, but there is actually no carbonite listed here. That was made up for Star Wars, The Empire Strikes Back. Remember what carbonite was for? To freeze Han Solo, exactly. So it's fictional. But if there were such a thing, it would be like CO2 2 minus or something like that. But CO2 is actually very happy being neutral. It has no charge. And so there is no carbonite. So, all right. So look for pairs of ions, which there's both an ite and an ate ending, like sulfite, sulfate, nitrite. Nitrate is not listed, but it would be NO3, 1 minus. And you'll notice that a lot of times they have the same charge. Okay, so the sulfs, both are 2 minus. The nites are 1 minus. All right. And the chlorites, the chlors, have 1 minus. And so you can see that. Now, hydrogen sulfate has had an H plus added, That's why it's not 2 minus anymore, because, you know, -2 and +1 makes -1. But if you're just changing the number of oxygens, oddly enough, most of the time, you don't change the overall charge of the ion. And then these ions float around just like they're giant atoms, just like they're giant element anions. So hypochlorite acts pretty much just like chloride does. Now, not really, because that's how we distinguish it, but in many ways, it just floats around just like a giant chloride ion would. Nitrite floats around like nitride would float around. I mean, it's just they've got more atoms, but they only do one thing. They only do one thing. It's like a truck and a trailer. Yes, it's technically two things. You know, it bends at the curves and that sort of thing, but it's one thing. Okay, it's two but one. So same thing here. Now, sulfite, sulfate, nitrite, nitrate, chlorite, chlorate, and you should see that pattern. Ite is fewer oxygens than the 8, but it still doesn't tell you how many. It's just like ferric versus ferrous, the old naming system for the ions that can have more than one charge, which is the first skill sheet I've assigned to you this morning. It doesn't really tell you how many, it just tells you relatively. So useful, but not completely useful, but we still do use that. We haven't switched over to some new system the way we did with the stock metal ion naming system. All right, so we have hydrogen carbonate, and yeah, we could call it hydrogen carbonate, but we almost always still call it the old name bicarbonate. So sodium bicarbonate is sodium ion with this thing, hydrogen carbonate. And so this is the stuff you've made volcanoes for in every science class from like 2nd grade. All right, now it's very important in your body. Hydrogen carbonate helps keep your blood pH buffered. Now, buffers are something that if this was a normal year and if this was an honors chemistry class, we would get to. This is a regular chemistry class, so we would never get to it, and this is a really weird year, so we doubly won't get to it. But I just want you to know your body depends on there being the right concentration, the right amount of bicarbonate floating around in your body. And don't worry if you get a stomach ache and you take an Alka-Seltzer, sodium bicarbonate, whatever, you're not going to ruin your body. You're not going to throw this out of whack by drinking that. If you make a habit of doing that every day, you might cause a problem. But then you've also got your phosphates, and they're not plain old phosphate. They've got hydrogens added there, and that's what's really in sodas. Is this stuff is floating around because the phosphoric acid almost immediately one of the hydrogens leaves and leaves dihydrogen phosphate, 2 hydrogens, and sometimes even this other one leaves too. But they mostly are in balance, and so you don't really have to worry about that. So. All right, I mentioned that. You don't want cyanide, on the other hand. The famous poison pill, right? We've all seen those spy movies where the bad guy gets captured and he chomps down on a fake tooth and then it gets all foamy at the mouth. That it's death from cyanide poisoning. It's nasty. Of course, they dramatize things for drama. Right, that's why we watch the show, is the drama. And you can learn more about that in English class. But you really don't want this one. Now, it looks nice. It's just carbon and nitrogen, right? Seems pretty innocent. But it isn't. So it's not because it has a -1 charge, because you have lots of things that are floating around your body that have a -1 charge. That's not the problem. The problem isn't that it's got carbon. Almost everything in your body's got carbon. Same thing with nitrogen. It's that precise combination, that precise shape will lock into the chemical chain of things happening in your cell, and then all of a sudden your heart stops. So it's not too good. Not too good. All right. So this is just a review. You have they persist in calling these the A groups, but it's 1, 2, and 13 as well. They will have the charge that's right above them in that pattern, 1, 2, 3. If you want to know for the anion, you just see how far to the left of the noble gas it is. For transition metals, you're just going to have to look at what the anion charge is, and then you can do the math and figure out what the charge of the metal is. So if there's a certain number of oxygens, which is always -2, then your iron or your cobalt or whatever will have a particular charge. If it's a different number, then it will, be different. All right. Polyatomic ions just act like a unit, okay? They just float around as one thing. All right, so monatomic, one atom. And again, we spent so many chapters looking at the periodic table because a quick familiarity with where the elements are, or even just memorizing which group things are in, makes all of the other chemical thinking much, much easier. And that is where I'm going to stop and let you work on your skill sheets I've assigned for you. So you may continue to do that. I'm going to turn on the lights in this room. And of course, please stay on the line for the Zoom call. And please ask any questions either in the chat or in out loud. Okay, I'm going to turn on the light. Go blind. Those of you on the Zoom call, have you any questions?
Not that I know, but I'll be sure to ask if I have any.
Okay. Just as a reminder that we are beginning now in Chapter 9. I am asking you to ask a question about the data on page 2. Some of you are asking questions about the topic from page 1. It's good to ask those questions. Please go ahead and ask those questions in an email or out loud. However, the assignment is to be about page 2. So the data, the fake data that's there. So those of you who asked a question about the data, then you earn the full points for that question. For those of you who didn't, then you didn't earn those full points. So please look at the data and come up with some sort of a question that is not just a repetition of a question you asked previously. All right. When you turn it in multiple times, you may use the same question for that one skill sheet. You do not have to come up with a new question every time you turn it. Like if you get a 4 out of 8 and a 6 out of 8 and an 8 out of 8, you don't have to have 3 different questions. But then when you work on the next skill sheet, you need a new question because it's new data, usually. Sometimes it repeats. All right. Please do ask a question if you have any. Just a reminder too to have you check your home access center, and if for some reason you have a blank, either do the thing that's blank or email me about it. I do try to get those updated as soon as possible. I'll go ahead and stop the recording since people don't need to watch 10 minutes of silence.